Hello everyone, for First Updates Now, I'm Tyler Olds, and you're watching Behind the Bumpers. It's a fun show where we dive into FRC robots and what makes them work. And today I'm here with team number 503 Frog Force from Novi, Michigan, and 503 traces their roots all the way back to 2001 and is on track to become one of the latest Hall of Fame teams with 4 event wins, 11 finalist appearances, 7 Engineering Inspiration Awards, and 20, count them, 20 Chairman's Awards in their history as a team. And I'm here with Lexi, Ryan, Arseny, and Joshua. We're going to be diving into their 2021 robot, changes they've made from 2020, and some really cool features on the spot coming up here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Lexi, we're going to be starting out here with your 2021 robot with the intake and following that power cell journey. So I want to hear all about, of course, changes you've made from the 2020 robot and some of the cool features that are on the spot.
All right, so one of the things you might be able to see, I'm not sure if you can, is from the 2020 robot to the 2021 robot, we actually got rid of a full roller. And there's a lot of stuff that we wanted to do with our intake. We also made the intake wider, and we changed it from being a virtual 4-bar, where one bar was the actual bar itself and the second was a chain, to being a full 4-bar. And we did this because we decided to make the robot bigger. When we started last season, we had a specific set of objectives that we wanted to meet, and we wanted to create a specific robot. But we decided, after going through our first competition that we were lucky enough to go to before COVID hit, that we wanted to change up how we did things. And one of those main things that we wanted to be able to do was we wanted to be able to intake 2 power cells at once. So that is what you can see here. This is able to intake 2 power cells side by side. So I'll run you through some of the specific features of it. One of the main things that we changed was that we changed the motor from a 775 to a Falcon. And what this allows us to do is we can intake things much faster, which is a problem we had before. The intake was too slow. We also rearranged the bars that we had to eliminate dead zones. You can see at the bottom, we have one roller that is actually significantly wider than the other 3 rollers, and it also has some grippy stuff on it, and that was to help eliminate some dead zones. We have little metal arms on the side that allow the balls to get fed into the center so that we don't have to worry about them not landing in our indexing system or landing in the gearbox. We also have a bar on the top added for stability, but we did take away some of the bars from the past robot so that we could save weight.
But Lexi, let me ask you on the bot here, how many different iterations is this product here? Like, did you just say, hey, we know exactly what we need to change and here it is? Or did you go through a couple different iterations to get to this spot?
Definitely not just something that we came up with overnight. We had a lot of changes on this. I would say this intake on our old robot is definitely a couple iterations in. And while we were locked down during the summer, we spent a lot of time looking at CAD and going over what we wanted to design potentially for the robot. And we went through several iterations of how we can improve it. And we really looked at everything. And what you see here is really the culmination of a lot of work that we've had over the past couple of months, be it virtual or in person when we were fortunate enough to, and it was safe for us to.
Well, let's keep moving on through the process here of the power cell. So we're going to be going over to Ryan next, who's going to be talking about the indexer and the feeder. And when we interviewed you guys last year, so go check that out as well, too. You guys got the cool spindexer going on in your robot. Love to hear about the changes on that. And then are you still carrying 5 power cells, or did you reduce to 3 for the at-home challenge?
So we can still carry 5 power cells, but the biggest design change was we went from the wall being stationary to the wall being mounted to the floor and also turning with the indexer. And another important change was we went from chain drive over to a belt, and we made the gearbox plates out of aluminum instead of nylon this time around, so it's a lot more stiffer. And then it changed from having the kicker wheel being just right below the shooter and only having one to actually having more of a feeder mechanism where we have omni wheels so the balls can rotate through unless we turn it on.
So on the feeder itself, as it comes through, what actually grabs the ball up into that? Is it those wheels there, or does something come down, or how does that power cell actually move into that feeder itself?
So the omni wheels will touch the ball, so we have them turned off when we're just spinning the indexer. But then when we want to grab the ball, we just turn that on, and then the omni wheels will grab it and shoot it up.
Oh, very cool. I'd love seeing the demo on that. That makes a lot more sense. Thank you. So we're going to go back over to Lexi, who's going to be talking about the turret and any modifications that are made for that. I mean, you guys had a very successful turret in the 2020 season, so I'd love to hear more about what you improved even more on this robot.
Yes, again, because we made the chassis of this robot a lot wider, we were able to put in a lot more cool features this year. So one of the huge things that we did was we changed from having a stationary shooter to a turret that is able to spin around quite a bit. It's very lovely. It's one of my favorites. It has several features. One of them, as you can see the turning here, with very nice wiring that we'll go into in the future. And you can also see that it has an adjustable hood so that we can shoot from several different distances on the field if you'd like to show that moving up and down. So this really allows us to be able to shoot from many different distances, whereas before we only had 2 positions on our hood, so we could only really effectively shoot from 2 distances on the field. And this robot is really just a lot more modular in its strategy, and it has a lot more versatility.
So this might be a question for programming later, but you said your old robot had 2 set positions. I know there's you can probably shoot from any position you want, but how many set positions do you actually have on the 2021 robot?
So we have various positions that we have actually gone through and thoroughly dialed in, aside from being able to shoot from anywhere on the field.
Mm-hmm.
One of them is near the very trench entrance, so that when we run our 11 ball auto, which basically entails driving backwards and it starts shooting while we're going through the trench, we want to always guarantee that all those shots go in. Another one is right up near the initiation line, because we know that sometime in the future we'll have some more autos to write that start on the initiation line and just shoot from there. And those same distances are guaranteed, as well as a batter shot that we which just presses up right against the goal and positions the hood and obviously the shooter speed such that it can at least make it into the outer port. And we're also going to have a future goal to try to rebound the balls off the ceiling of the goal in an optimized position to get it also in the center port.
That's awesome. I know we're going to be hearing a little bit more about some of the programming features in just a little bit as well, too. But let's go over to Arsene. He's going to be talking about some of the electrical and the packaging that goes in on this robot. And Arsene, I'm going to start out by asking you, this is something I've asked a couple of teams already. In the electrical and the robot, where does the hierarchy of electrical land? Do you get to choose where it's going first, or does mechanical get their way and they're like, here, make this fit afterwards sort of thing?
It kind of depends. In a lot of cases, it's usually mechanical first, especially for the turret this year. It was definitely completely designed first, and then the electrical was figured out after.
Sure.
So and that's kind of evident by the additions of these plastic things on the sides here. So typically on our team, mechanical does get to do all their stuff, but they do tend to leave us a decent amount of space to innovate and stuff like that.
So they give you some consideration at least.
Yeah.
All right, that's good. So walk me through some of the other packaging on this robot and any specific sensors or anything like that you want to talk about.
Well, there's 2 major innovations that we have done from last year. So one of the major changes from our robot last year for electrical was the addition of a turret, because it's a bunch of new wiring that we didn't have last year, obviously. And the way that our turret wiring system works is we have all of our components on the actual turret itself. Then we have every wire that goes to those components including CAN, PWM, power wires, and even Ethernet, going through this one wire bundle here, back down to the electrical system below. When the turret rotates, it will rotate the wire around itself, and then when it rotates back, it'll kind of coil up in that little area there, as you can see right now. Now we played around with a couple of different variations of this system, and currently we have this one where the wire just kind of freely coils in this little plastic thing. This may be changed later because we were originally playing around with a linear slide system where we would have springs pulling the wire back and the wire would be moving on a linear slide. However, that system didn't end up working very well because the wire pulling on the linear slide would cause too much friction, and so it wouldn't actually pull back correctly. So we may edit this in the future, but for now, this seems to be working pretty well. So that's all the turret stuff. And then the second major innovation would be actually on the underside of the robot, where we've changed up the electrical system from last year. So we're going to flip the robot onto its front now so you can see the underside with its electrical system. So you may notice that we have pretty much the majority of our components mounted upside down, and you can see that through a clear belly pan here. Ever since we first designed our swerve back in the summer of 2019, we've been playing around with upside down electrical systems. So this one is our latest design, and it improves several of the aspects from the previous two upside down electrical systems we've designed for swerve bots. This one has a major change of having a belly pan that will actually hinge, and this allows much easier access to stuff like the Rio, because the Rio is not mounted upside down. We discovered in our very first upside down electrical system that having the Rio upside down was a bad idea, because many of the ports on there are just held in by gravity, and so wires will tend to fall out over time. So that's why we have that here. On the 2020 robot, we had the Rio not upside down still, but it was mounted on a plate that was hanging from some standoffs off of the upside down electrical ceiling. So this caused problems because you couldn't really reach it super easily. So for this one, we have the wires going where the hinge is, right there, so that when you actually unfold it, the Rio and anything else that we mount on the actual hinging belly pan is just open for us and easy to access. And it just folds up nice and neat like that. So that's the major change. Another change that we have on here is the battery. It used to be in the center, but for this particular robot, we decided to move it down here because of the whole superstructure being in the back of the robot.
Sure.
So we decided to kind of balance out the robot there. But it's a very similar design to the battery system we had last year, where we have this cover that will open and the battery will come out basically.
Yeah, I love the accessibility of that. Obviously you've done your homework on that. I think it's really cool the way that's been designed. Definitely one of the more unique ways I've seen that design as well. I do have to ask, not quite an electrical follow-up, but just since I noticed this on here, and so I'm not sure who would be best to answer this, but can somebody talk a little bit about your drive pods? Why are the ones that are towards the top of your robot right now, why are those different than the ones at the bottom? Or what is that housing that's on there?
So these swerve modules, since we were trying to stick to a reasonable budget on this robot, came off of last year's practice bot. So we had the top ones, which are 3D printed. So that's just one of the designs. And then
Sure.
we had the metal fork design. So that's just what we had. And for the time frame we had, we just wanted to get the robot driving. So that's what we put on the robot.
No, totally makes sense. Wasn't sure if there's anything in particular with it or not, but had to ask since it's very apparent on the differences. So let's go ahead over to Joshua and wrap up some of the other programming features I know Joshua wanted to showcase. And then I think at some point we'll be taking a look at a couple of the runs the robot will be making as well.
Yep. So to start off with our programming, we also have a swerve drive again this year. So to do that, we have on the fly motion profile control for all of our 4 swerve module azimuth motors, which allows us to track all of them into a certain direction consistently. So I can give a quick demonstration of that.
Yeah.
I'm going to go over to the drive station here. All right. Enabling. So I'm just going to like go forward first. Oh, hold on, I have to reset the gyro. All right. That's another thing I'll talk about next is, so here we're going forward. And as you can see, I can track the modules in all 360 directions accurately. And they continuously follow each other to one vector. And then if we mix that with some rotational inputs, our inverse kinematics will calculate how to translate and rotate at the same time.
That's really cool. And is this something? When did you develop this as well? Like I know you said you've had Swerve for a couple of years, so is this something that came with that right away, or is this something new for you in 2021?
So we actually already had our Swerve inverse kinematics code from our last year's 2020 robot, but some of the changes that we've had to make for this year's skills challenges, we're being able to in our autonomous modes, like accurately navigate tight corners in a smooth fashion. So especially with like some of the auto nav paths, we used a new follower this year and also a new path generator. So last year, because we had Swerve, we only had to generate paths that follow line segments and arcs. But this year we added code that actually generates like quintic Hermite splines, which are generally like the kind of geometry that tank drives will follow. But we realized that for this year's challenge, it's still very helpful to have those kind of smooth curves so that are accurately around tight corners. The other thing is in our actual path executor or the follower, we added acceleration control. So it also tracks the curvature of each of the paths and puts the tangential and normal acceleration components together so that when we're navigating a tight corner, it knows to slow down the modules in whatever X components or Y components so that we never overshoot or try to skid the swerve modules, which will really majorly disturb our localization because it runs over odometry.
Yeah,
So
no, that makes total sense. That's so cool, man.
Yeah, so we're gonna put the robot down and we can actually show some of like the field-centric drive approach that we also have. And this is another thing I carried over from last year. One of the features that we're yet to carry over, because kind of one of our goals is to be able to shoot while driving, is also still having an X mode available, which basically locks all the swerve modules in an X formation, which if you think about it in like with an analogy to a tank drive, it's like being T-boned, but you're being T-boned from like all the directions. Because like regardless of which direction you're being pushed in, it's a swerve drive, the wheels are locked in that formation and you just can't move over. So that's another feature we're going to transfer over. So now I'll show some of the field-centric drive approach. So enabling. So if we reset our gyro to a certain position, we're able to optimize the driver's inputs such that they can think of it in the context of the field. So like this is obviously forward and backward, but the robot's facing forward. So if we angle it, we drive it forward and backward. It still drives forward and backward with respect to the field. And the reason this is really important is that we can actually translate and rotate at the same time without having to worry about the robot using it forward. So basically, our robot really doesn't have any designated front, and that gives us just a lot of maneuverability in our teleop period, especially.
Well, before we wrap up here, your team has prepared a couple of the AutoNav challenges and also a Galactic Search challenge. So let's go ahead and take a look.
3, 2, 1, clear. 8.03. 3, 2, 1, clear. 0 north. Clear.
Well, 503 Frog Force, thank you so much for taking the time to tell us about your robot. I mean, you have an amazing team, not only, of course, on your robot side, but everything you've been doing, of course, through Chairman's and your EI awards and everything else you've received. Very well earned. What an impressive team coming out of Michigan, and we can't wait to see what else comes out of your team in the future. Good luck. We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.